Hi, in this video, I'm going to talk about a couple more examples on existence and uniqueness of first order differential equations. Okay, so in the last video we discussed a few more examples there. Now, so on both of these examples, we will talk about how the different initial values changes the behavior of the solution when t increases. Okay, all right. The first example here is solve the initial value problem. Y prime plus y cubed equals to 0, y at 0 equals to y sub 0. Determine how solution appears as t increases. Okay, t going up, that arrow or the pointed line up is t increases, and how their behavior depends on initial value. Okay, so let us, because it says determine how the solution appears, right? So let us solve this. You have let me solve this solution. You have dy over dt equals, let's write out negative y cubed, right? And then y at 0 is y sub 0. Here, the very first thing that I want to mention on these both problem is, look at this. The right hand side is f, right? Here the right hand side we denote by f. In both of these problems, the fy, so f is a function of y here f is a function of ty, right? So this function y cubed, that is f equals to y cubed, and what is f sub y will be negative 3y squared, right? Here, what is f sub y? F sub y will be, so it will be t times, right, 3 minus 2y. So both of these f and fy, f and f sub y, that is the partial of f with respect to y, are continuous everywhere. Okay, you see that? Both of these example, the right hand side f, the right hand side function f, and their derivative with respect to the y are continuous everywhere. Okay, so we don't need to worry about whether there is a solution exists and if it is unique or not. They are, yes, there are solution exists for each of these problems, and they are unique as well. Okay, now what we want to do is we want to answer these questions because we don't worry about the existence and uniqueness of the solution, because it is obvious from the problem. Okay, guys. All right, so let me remove what I had there and then start to do the problem. So this can be written in the 1 over y cubed variable separated form, right, equals to dt, right? You can write negative dt. And then if you want to integrate on both sides, how do you integrate there? Is you integrate here, you integrate like that, right? If you have to move, this will be moved to the y to the negative 2 dy equals to negative t plus c, right? That's what you get. So what is the integral of y to the negative 2? It will be y to the negative 3, I'm sorry. Negative 3 plus 1 over negative 3 plus 1 equals to a negative t plus, I mean, you can write negative dt here and then c, that is like c1, and then you get a different c here. Why? Because you get another constant of integration here, right? I combine that with that c. So what you get is negative 1/2, right? Y squared, let's do that. Negative 1 over 2 y squared, right, equals to negative t plus c. So what I'm going to do next is I want to use y at 0 equals to y0. What do you get? If you do that, then you will get negative 1 over 2 y0 squared equals to c, right? That's what you get for c. Now how do you put that back? It looks like, let me do like this. So let me plug in the value of c. You get negative 1 over 2 y squared equals negative t minus 1 over 2 y0 squared, right? You can multiply both sides by negative 1, just because all of those terms have negative sign, right? So what you can do there is you can write like 1 over 2 y squared equals to t plus 1 over 2 y0 square, right? That's what you get. Now, how do you solve this for y? Is let me write down like 1 in the bottom and then combine that 1 over 2y square equals to 2ty0 square plus 1 over 2y0 square, right? If you multiply both sides by 2, you cancel out that 2 and 2, then you get, basically you will get this. You get 1 over y square equals to 2ty0 square plus 1 divided by y0 square. Now flip flop, okay, you get y square equals to y0 square divided by twice ty0 square plus 1. This is what you get. And if you take the root on both sides, you will get y of t, because these all y's are y function of t, right? Equals to, and the root of the top will be y0, right? And the root of the bottom will be under the root 2ty0 square plus 1. This is what you get. Okay, now what we want to do is, when t tends to infinity, what happens? When t increases, what happens to the solution? Okay, so and then it says, and how their behavior depends on the initial value. So what happens if y0, so what we'll do here is, if y0 is positive, y0 is negative, and y0 is 0, right? So let us do that part. If y0 equals to 0, then what happens? Y of t becomes 0 for all t, right? All t. Why? Because when y0 is 0, then this will be 0 over, that is 0 plus 1. So 0 over 1 will be just 0, right? If y0 is greater than 0, what happens? If y0 is greater than 0, then so this solution exists only if the denominator is positive. This quantity is positive, right? Otherwise the solution will not exist. And this is true if y0 is less than 0 or y0 is less than 0. If y0 is greater than 0 or y0 is less than 0, which that is what that means, y0 not equals to 0, right? In this case, this will be positive or negative, it does not matter, but the solution exists only if the denominator is positive, right? Then the solution exists if twice ty0 square plus 1 is positive, right? It cannot be 0, because if the denominator is 0, then you will get infinity for y. So if you solve for t, what do you get then? If you solve for t, subtract 1 and then divide by y0 square, you will get t, that is t is greater than negative 1 over 2y0 square. So if y0 is equals to 0, then the solution is y equals to 0. If y0 is not equals to 0, then the solution exists only if t is greater than negative 1 over 2y0 square. Okay, so at that time this will be the solution actually. Okay, this is the condition and this will be the solution at that point. So let us look at another example there. So an example, the second example, it says draw direction field and plot several solutions of the differential equations dy over dt equals ty 3 minus y. Initial value is not given. So what we will do is, the question is asking what happens if you take the different initial values there. Okay, describe how the solution behaves as t increases, t and then pointed arrow up means t increases, and how the behavior of solution depends on initial value. That's what you want to do here. So in the last chapter, actually in chapter 1, we learn on how we draw the direction field, right? So for each value of t and y, we plot that t and y. For example, plot t equals 0, y equals 0, t equals to 1, y equals 0, t equals to y equals 0, and so on. And t is 1, y is 1, t is 1, y, t is 2, y is 1, t is 3, y is 1, and so on. If you do that, you will get shortened direction field. But for simplicity, for convenience, what I'm going to do is, I'm going to use the same app that the word is it is homepage.bluffton.edu/ and then that symbol, wiggle symbol, and nested /apps/slopefits.html. So this is the app they have created. Thank you for them to make our life easy and handy. Okay, So what I'm going to do here is I am plotting. Let's look at that. The right hand side of ty 3 minus y, t times y times 3 minus y. So the variable is dy over dt. So what I picked is I picked -5 to +5 for t and -5 to +5 for y. Okay guys, so you can increase that to 20, not a problem. Okay, you can make 20 on both. So the question is asking plot the several solution. What you do is you can click several places, okay, to see the several solutions. All right, so if your y0, if the initial value is less than 0, then all the solutions are, when t is increasing, then the solution is going to -infinity. Did you see that? This guy is going to -infinity. Now if let us say if y0 is greater than 0, if the initial value is bigger than 0, look at this. For the bigger than 0, this is what is happening, right? Look at that. All the solutions are approaching to 3. Y equals to 3, right? For any value greater than 0, any initial value greater than 0, it is going to 3. Any initial value less than 0, it is going to -infinity. But if the initial value is equals to 0, if initial value is exactly 0, let's say it is picking close to, okay, not, if it is exactly 0, then in that case you will get y equals to 0. Okay, so how do I write this then? So let me write down there. So if from the direction field, what do we get? We got, but if y0 is less than 0, then y of t, that is the solution, goes to -infinity as t increases, right? If y0 equals to 0, then y of t will be 0 as t tends to infinity, or t is increasing as t increases. And if y0 is greater than 0, then in that case y of t is going to +3 as t increases, right? This is what we found from the direction field. Okay, so this is the end of section 2.4 from the book. Okay guys.